Hi everyone, this is Saad Aslam and welcome back to an exciting series on competitive programming. Meanwhile, throughout this series, I have discussed a couple of problems on hash map and using stack data structure and other data structures too. So, today we are going to discuss a very interesting problem that is a valid anagram problem. Okay, so let's first discuss the problem statement and then we will go to the approach of it. So let's first discuss the problem statement. So here you can see, let me just, so here there is a valid anagram. So given two strings s and t, return to if it is an anagram of s and otherwise false. So basically, anagram is just a rearrangement of the letters, or you can say that it is a rearrangement of different letters of a word. Okay, so we have to find if the both of the strings are like anagrams of each other or not. So here you can see in the example one that a string s is an anagram and t is a rearrangement of it. And here we can see when we sort both of the two, then both are same. So we have to return true in that case. But in the example two, string one is rat. Here you can see string one is rat and the t is car. So like both cannot be same. So we have to return false in that case. Okay. So before jumping to the goal, let's first understand the approach in a whiteboard section. So let's go to the whiteboard section. Okay, so in whiteboard here you can see I have already implemented array. You can see first we have to find the two approaches we can use. Okay, so the one approach can be simple, like we can use a hash map approach. Okay, so what it can be like, we have to first sort the both of the strings. Okay, so we have like sort the strings and we can use a hash map. We can add the first like string s1 is added in the hash map, and after sorting string t, we will find if the map contains the, you can say, the word, then return true, otherwise it return false. But here we in our case we have just have to compare two strings, so we can use a more simple approach, because in hash map we have to use it can be more it can use more space, and sorting there will be some sort of time complexity too. So we can use a simple approach rather than using hash map and that. So we can just use like, we can store the index. Okay, like we can increment the frequency at the current index. Okay, so like the index of, suppose in anagram, here you can see in anagram the index will be stored and we have to increment its frequency. Okay, and for the other string t, we just have to check like the if the element at the index, the element present in the index, we have to just decrement the frequency. And after checking both of the frequencies, if the frequencies of all the elements are zero, it means that both elements have the same occurrences of numbers. Okay, so it means that if we rearrange the elements, then they are both this are same, that they are anagrams of each other, that they're rearrangement of each other. Okay, so for making sure like to not using any extra time, I've just already mentioned the indexes of the elements, letters that are going to be used in the string anagram. Okay, so the word a, the like suppose the word a, the index of the word a is at zero. Like in the alphabet, the letters, we have to find the like indexes of the alphabet. So what, a occurs at zero, so we have to just increment its frequency. Now suppose it, we have to return one. Okay, and the next element is n. Okay, the next element is n. So n occurs at the index n 13. Okay, so we have to increment its frequency by one. And when we now the element is at, the element is at you can say the element is now at A. So we have to just increment the frequency. Okay, so we have to increment it to 2, like it has occurred twice. Then the next element is G. Okay, so we just remove the element, and the next element in our iteration is G. So G occurs at index 6. Okay, so we have to increment its frequency. The next element is R. Okay, so R, the next letter is R. R occurs at index 17, and similarly the index A, we again encountered A. So now we have to find A, and we have to just increment its frequency, like it will be 3. And finally we have M, then M occurs at index 12. Okay, so this is for like we have stored the frequencies of the letters that have occurred in the word. Okay, so for the second, like we have taken the, and the second string is like as just okay. So the second, why it is not working? Okay, so the second string is this. Okay, we just have to make it here. Okay, so for the second string, we just have to decrement the frequencies at that index. Okay, so first is n. Okay, so the first is n. N occurs at what index? 13. So we just have to decrement it, and now it is at 0. Now then a is for let's simple go to a, then it will be 2. Then the next letter is G. It occurs at 6, so now it is 0. The next is again A. Now decrement it, and it is, what is it? Is again 1. Then it is R. R it has 7. We decrement it, then it is 0. Then it is again A. So we decrement it, and it is again 0. And the last element is M. It is at index 12. So we decrement it. So here you can see, like after decrementing, we the array is something like all the elements are 0. So when we find an array when like all of the elements in an array are 0, then it means that both are anagrams of each other. So that is the logic, that is the approach we are going to use, and let's just quickly implement it in our coding part. So let's find out how it works. Okay, so let's quickly go to the coding part. So as usual, we are going to use Java. Okay, so let's find like the first edge case we are going to use. The edge case is something like if the lengths are not same, then we simply have to return false, like if they are not having equal lengths. So if, oh sorry, okay, if s dot length not equals, okay, we just having, okay. Okay, so as dot length and length not equals, then we just have to return false. Like if the length is not same, like if one string is greater and they like there is ABC, another is AB, then it is simply straightforward, and both are not equal. Okay, so we can like it can be the base condition. We can say we just have edge case. We can say we have to test, and then we are going to initialize array there that are going to store the frequencies that we have just did in our whiteboard part. So it will be new int, and as letters in the alphabets are 26, so we have to initialize it 26. Now a for loop that will traverse to both of the length of the string. So we can take the length of s or t in, because in our case it will be equal If the lns are not equal, it will have returned in the earlier part of our code. So for int I is equals to 0, I is less than suppose t dot length. Okay, and we are just I plus plus, and the loop will traverse first string. Okay, like it will check the index at the string one, and it will decrement the value from the string two. Okay, we are doing both in one loop. So like ch count s dot character s dot character at s dot character at I, and we have to. So basically, what minus a will do is like it will return the index. Like, okay, so the character at minus the character minus character a, it will return the index of that uh, letter. Okay, so plus plus. So the string from string first string it will increment, and from the other string we have to decrement. Okay, so character count e dot character. Similarly, okay, and it will decrement. And okay, so after this part, we have to check like if the character count, the array we have initialized, if all the elements in the array are zero, then it means both are anagrams of each other. Otherwise, we have to return false. Okay, so let's make another loop of int count. Okay, and it will loop through the for each loop, like it is a for each loop of count, and if count not equals 0, like it is not equals to 0, then we have to return false. Okay, otherwise we have to return 2. Okay, so let's just test this code. Okay, character count s dot. Okay, the first t h l e n t h equals to return false. Okay, th. Okay, so here you can see that is a pass the test cases. Now let's submit this, and okay, so it has been like submitted successfully. Here you can see like how we can use very simple approach of how to finding the anagrams of each other. So if you like this video, make sure to subscribe my channel and all of the YouTube stuff, and hopefully see you in the next video. Till then, bye bye.